So you've bought your kit from eVelocity and you're now at the point of where you need to assemble this thing. eVelocity does give you an assembly instructions, but I thought what I'd do is, before we get into that, is just talk about some of the tools that you would need to do this particular job. A couple of things I use is a long nose pliers and a side cutters. Quite handy to cut off little things and do a bit of bending, so get yourself some of those. A Phillips screwdriver, also really handy. I like to have a tweezers handby, only because it makes sometimes some of those fine work a little bit easier for me. Then I also have a solder sucker for when there's a bit of a problem and you need to remove some of the unwanted solder. I also use solder wick quite often with some flux, which just makes that whole process a little bit easier. The other thing that's quite important is the solder. This particular solder is 40% lead, and I find that it flows really well. The other thing you need is obviously a soldering iron. Now I'm going to use, for me, I'm going to use my temperature controlled one from my workstation, and what that means is that I can control the temperature in the tip here, and I'll probably set it to around 180 degrees because the solder here melts at about 150, so we'll use about 180 and see how we go. Might need to pull it up to 200 depending on what we're doing. So definitely a good soldering iron is a must. The other thing that I will be using is a multimeter, and this is very handy to test circuits and work out the resistance of your resistors. You can decode the bands or just simply measure it. In the next video I'll talk about a little bit about the components, and then we'll get on to assembly. PCB has got the printed circuit board, and it's got all of the components labelled on the top. So this is the top side, this is the bottom side. See, there's no component labelled. This board is where we're going to install all of the components. With that PCB we have got the heatsinks. There are two of them. These guys are for the FET, so we can keep them cool, otherwise they tend to overheat. We have got terminals, one of these and three of these. These are where we are going to attach the power and the motors, and a couple of connectors. Pretty simple. With that other thing, we've got a 3.5mm earphone jack, and this is to program the pickaxe. The guys that look like this, these are resistors, and they are all different values, but what you can do is, if you can decode the color code on the side of them, that will give you an idea of what the value is. I'm going to cheat, I'll just use a multimeter and measure them and write their value up here so that I know which ones I'm grabbing. Capacitors, there's a couple of these. There's a number printed on here, and that number will give you the indication of what the value is of the capacitor. This is a ceramic capacitor. There's one of these in a little bag of another ones. This is also a capacitor. This is an electrolytic capacitor, and this capacitor has got a negative leg, which is also noted by having a short leg. Make sure that you install this guy the right way around, otherwise they tend to get a little bit annoyed about things. Then we've got, I'm going to put them over here, we've got some Zener Diodes, and the Zener Diode has got a negative leg, and that is shown by the little black band on the end. There's a number printed on the side of these. You can't see on camera, but I'll just use my microscope to figure out which ones I have, and we need to make sure that we install them the right way around as well, with the little black band in the right place. LED, same deal applies with the LED. Short leg, negative leg, but if you don't know which one it is, there's a little flat on the side of the negative leg, so you can quite easily work out which side is the negative leg that you're going to be working with. Then we have some of these. Now they all look the same, but the number on the top of them is different, and that will tell you which one you've got. In this case, I've got a LM7815C 15 volt regulator. We've got another one here which is 7805, that's the 5 volt regulator, and then we've got the two FETs, which is an IRFB number. So these guys, we don't want to get mixed up with those ones, because if you install them in the wrong place they don't work. Other little transistor that we have is this little BC transistor, little guy, also important to install that the right way around, but the printed circuit board is pretty clear on that. Then we have our FET driver chip. It's an IC chip. Now the thing with these chips is you'll see that there's a little cutaway there and there's a little dot over there. That is to show that's pin number 1, and that's the top of the chip, and we want to make sure that we install this the right way around, because putting it in backwards is going to make things quite interesting and not work. This particular chip drives the FETs and will turn the FETs on and off. Then we have this little guy over here, a little 8-pin IC. Again, we've got the top of the chip over there, and this is a comparator chip. It's a LN393N, I think, if my memory serves. I can't look underneath the microscope, but we also need to make sure we install this guy the right way around. Then we have this little socket over here, dip 8 socket, and that means that we can install the chip in and out while we're going. We want to make sure we put the little slot in the right place, and we're going to use this with the pickaxe chip so that we can take that pickaxe in and out. Now the pickaxe chip here, I've got here again, it's got the little notch over there and the pin number 1, but this guy is the microcontroller that makes this whole lot work. So we want to make sure that we can pull that in and out and change the programming on it, or just program it through the earphone jack. The last little thing that's important is this guy here. This is a Hall effect current sensor, and we need to make sure that when we install this that we get these pins in the right place, otherwise the comparator circuit doesn't work that well. Right, so I'll go ahead and work out my resistors, and then I'll shoot the next bit of a video.